Hello and welcome to another video of Excel Bonanza, and in this video we're going to get an introduction to Power Pivot and DAX, and we're going to explain why they are so powerful and why you should learn them as soon as possible. Okay guys, so let's speak about DAX. So what is DAX? So DAX stands for Data Analysis Expression, and DAX is the language used for writing formulas in Power Pivot and in Power BI. So Power Pivot is the Excel add-in that's been added to Excel since Excel 2010 that allows you to handle tables with millions of rows and create relationships between them. And Power BI is another business intelligence tool produced by Microsoft, and they both use DAX to write their formulas. So whatever you learn in DAX will be applicable in both Power Pivot and Power BI, and it allows you to manipulate the filters on your tables and perform powerful calculations. And it gives you a lot of power when performing calculations that you otherwise do not have in the normal Excel. And the DAX engine can handle tables having millions of rows, which is beyond the capacity of regular Excel. So you know that the regular Excel's capacity is around 1 million rows. So DAX can handle tables with millions, even tens of millions of rows without any problem. So the DAX engine is very powerful and it can handle tables with a huge amount of data. Okay, so before we continue with the video, I'd like to tell you that I'm currently creating courses on Power Pivot and DAX. So if you'd like to be notified when the courses get launched and also get the early bird discount, please make sure to subscribe to my newsletter through the link below in the description. And please make sure to subscribe to my YouTube channel as well. And of course, I will be placing the links for the courses below in the description when the courses get launched. So please make sure to check the description anyways. And now let's continue with our video. Okay, so let's speak about Power Pivot and how you can enable it in Excel. So if you have Excel 2016, 2019, or Office 365, you should be able to enable the Power Pivot tab here on the ribbon by going to File and then going to Options and then going to Add-ins and then going here to COM Add-ins and then clicking on Go, and then you should be able to activate Microsoft Power Pivot for Excel and click OK, and you will have the Power Pivot add-in here. However, if you have Excel 2010 or 2013, you will need to download an add-in first and set it up on your computer. And then you need to follow the same steps that I showed you here in order to activate the Power Pivot tab on the ribbon, and I'll leave you some links on how to download the add-in for Excel 2010 and 2013. Also, Power Query, which is another add-in, is available by default in Excel 2016 and upwards, so 2016, 2019, and Office 365, and it's available under the Data tab here on the ribbon. However, in Excel 2010 and in 2013, you will need to download an add-in as well and set it up, and I'll leave you some links on how to do that. So let's speak about Power Pivot. So in order to demonstrate Power Pivot, we need to import data into Power Pivot. And in order to import data into Power Pivot, we have two options. We can either use the Power Pivot window, and that is by going to the Data tab on the ribbon and clicking on Manage Data Model, or we can go to Power Pivot tab on the ribbon here and click on Manage. And here we have the Power Pivot window, which would contain our Power Pivot data model. But a data model consists of tables, and we still have not imported any tables yet. And this is why we don't have any tables appearing here. But when we import some tables, we will have some tables here at the bottom. So here you can see here that we have under the Get External Data group here under the Home tab on the Power Pivot window, we have options to import data from different sources. So we can import data from databases, from SQL Server, from Access, from analysis services, and we have the option to import from some data services, from OData, data feed, and from other sources as well. However, the Power Pivot window is not the best option for you to import data into Power Pivot because it has limited data manipulation and data transformation options. So the better option is actually the second option, which is using Power Query. And that is because Power Query has a lot of options when it comes to manipulating data or doing data transformations and cleaning your data. So you can pivot and unpivot your data, you can clean your data, you can do a lot to your data using Power Query than here using the Power Pivot window, which here on the Power Pivot window, you almost cannot do anything except remove columns. So we're going to use Power Query instead of the Power Pivot window to import data. So I'm going to close here the Power Pivot window, and in order to use Power Query, you can either go to the Data tab on the ribbon here if you have Excel 2016 or a later version, and that includes Office 365, or if you're using Excel 2010 or 2013, then you should have a Power Query tab here on the ribbon. Under that, you will have the same options here. So you can see here we have an option to get data under the Get and Transform group here, get data, and you have many options to get data from. So you can get data from a file, from a database, from Azure, from other sources too here. So you have many options on your data source, where to get your data from. So my data is in some text or CSV files, so I'm gonna click on that here from text or CSV, and the first table here I'm gonna import is my customers table. So I'll be importing these tables, and I'll be also creating a calendar table too. So I'm gonna import my first table here, which is the customers table, which is in a CSV file. So I'm gonna double click on that here in order to import it, and you can see here it gives me a preview of what my customers table looks like here. And I have two options. I can either load the data right away, or I can transform the data. It's better that I click on transform data, because then I can do a check on my data and make sure everything is okay and do any transformations if I need to. And then I can load the data into the data model later. So I'm going to click on transform data here. And as you can see here, my customers table has been loaded here. So as you can see here, it's detected my customer ID and my territory ID. It's detected both of them as a whole number. It's better that we make these a text, because these numbers, we're not gonna perform any arithmetic operations on them, because these are just IDs, they are keys. They are not numbers to perform any mathematical operations on them. So I'm gonna transform both of these into a text data type. And here, if I expand the navigator pane here, I expand my queries pane, you will see here it will list a list of my queries. So this is a query, and a query is basically a way for me to get data from somewhere. So my first query here, which is getting the customer's data from a file, and here you will see here I will have the source, and if I click on this gear here, it will show me the link for the file that I'm getting the data from. So I've got my customers table. I can also get more data here. So I can actually right click anywhere here on the queries, and then new query from file, from a text or CSV file, and I can import my second table here, which is the products table. So I'm going to import that as well. And I'm going to click OK here. It shows me a preview of my data, and I'm going to click OK. And now it's showing me my data here. And also for the product ID, I'm going to make that a text instead of a whole number, because this is not a number that we're going to do any arithmetic operations on. And also for the product category ID and the subcategory ID, I'm going to do the same. I'm going to make these a text. And I'm just making sure here that my data is okay and that there are no problems with it. And now I'm going to import my third table here. I'm going to go into new query, file, from text or CSV, and I'm going to import my sales table. So my sales table contains my sales transactions, and I'm going to click OK here. And first of all, let's make our IDs here a text as well. So I'm going to make the customer ID and the territory ID and also the product ID and the sales order ID. I'm going to make all these text. So I've changed the data type for these. And here my order date, if I check it, it's actually being read as a text, but I need that to be a date because it is a date. But let's see what happens if we convert it to a date. Let's try converting it to a date, and I'm going to replace the current data type, and as you can see here, I had an error when I tried to convert it to a date. So life is not perfect, and sometimes you will need to do data transformations on your data in order to have things done correctly. So as you can see here, I got an error when I tried to convert that to a date. So I'm gonna cancel this last step here of changing that to a date, and I'm going to have to do a data transformation to the order date in order to create an order date out of that correctly. Okay, so what we're going to do in order to solve the problem on our order date is I'm actually going to split my order date column here. So I'm going to select the column, and then I'm going to go to the transform tab on the ribbon, and then I'm going to split the column, and I'm going to split it by a delimiter. And the delimiter is going to be the / here, and I'm going to split it at each occurrence of the delimiter, which is going to split the column into 3 columns, one containing the day and another one containing the month and a third one containing the year of the date. So I'm going to click OK here, and you will notice that the order date has been split into 3 columns, order date.1, .2, .3. So I'm just going to name this order date day, and then I'm going to name this one order date month, and I'm going to name the third one order date year. So one containing my day, one containing my month, and one containing my year. And as you can see here, all of them have been identified as a whole number here. Now I'm going to create a custom column that will create the date out of these numbers, and I'm going to use the date function. So I'm going to go to add column, custom column, and I'm just gonna name this order date, and I'm just gonna create a column using the date function. So date, and you need to enter the year, comma, month, comma, day. And if you click OK here, so I've got my order date now, and if I try to make the data type for this a date, it will work without any issues. So I'm also gonna make this column, I'm going to move it right to the beginning of the table, so to the very left hand side, and then I'm going to delete these 3 columns here because I don't need them anymore. And Power Query will basically apply these steps each time it refreshes the sales file here. So as you can see here, I managed to solve the problem of the order date. Now let's import one more table, which is the territories table. So I'm going to right click, new query, file, text CSV, and I'm gonna import my territories table as well, and I'm gonna click OK here. And as you can see, I only need to convert the territory ID into a text. Here we go. So I've converted it into a text, and now we've imported our 4 tables here. Now there is a 5th table that is actually very important, and you will need to create this table in all your data models that you would create on Power Pivot, which is the calendar table. Now let's create the calendar table. Okay, so let's now create our calendar table. So we're going to use Power Query in order to create our calendar table. Now calendar table will contain our dates. This is going to be our dates table basically. And in order to do that, I'm just going to right click here and go to new query, and then other sources, and I'm going to create it from a blank query. And I'm going to use the M language, which is the language used to write code in Power Query and to write the Power Query functions in order to create that calendar table. So I'm going to write equals, and then I'm going to use a list function, which is the list.dates, and I'm going to open brackets here, and the first argument here for that function is the starting date. So what is the start date for my calendar table? Well, my sales table, and I know that because I've seen my sales table, it has dates between 2011 and 2014. So I need my calendar table to span all the time between the 1st of January 2011 until the 31st of December 2014. Okay, so my starting date will be the 1st of January 2011. So the date function, it will take 3 arguments. First the year, and then the month, and then the day. And I'm going to close that. And then I'm going to put a comma to input my second argument. My second argument is the count. I'm just going to put 1000 for now. And I'm going to come back to the argument later. So this will give me basically 1,000 days. So the count as number is basically going to be the count of days, or the count of iterations actually, that we're going to get. Okay, and then the third argument is the step as duration. The step is basically how many steps do you want to have between each day and the other one. So if you put 1, then it's going to be day after day, but if you put 2, then it's going to be every 2 days, but we want them to be day after day because we don't want to have any gaps on our dates, right? We want our calendar table to span and cover all the dates between 2011, the beginning of 2011, and the end of 2014. And now the third argument is the step as duration. I'm just gonna put here a hash, and then it's gonna be duration in lowercase, and please make sure to adhere to the casing of the functions. So duration should be written in lowercase, and date function as well should be written in lowercase, because the M language, which is the language that we're writing the Power Query functions in, is case sensitive. So duration is going to be duration, and then it's going to be days, and then hours, and then minutes, and then seconds. So the duration is going to be 1 day, 0 hours, 0 minutes, and 0 seconds. Okay, and when you press enter, you get this list of dates. So let me just translate what we've done here in plain English. I have written this function, and this function says, please list me the dates. And these dates start on the 1st of January 2011. And I need you to go 1,000 steps after the first date. And the value of each step is 1 day, 0 hours, 0 minutes, and 0 seconds. So the value of each step is 1 day, basically. Okay, so I need you to start at the 1st of January 2011 and move 1,000 steps forward, and the value of each step is 1 day, which will give you 1,000 days from the 1st of January 2011 onwards. However, this 1,000 steps, we want it to be exact, because I just put an arbitrary number here, but I don't know how many days exactly are between the 31st of January 2014 and the 1st of January 2011. So in order to compute that value exactly and get the exact value correctly, what we need to do is to subtract the two dates, right? So I'm going to subtract here date 2014 12/31, which is the 31st of December 2014. I'm going to subtract from that value the 1st of January 2011. So it will give me the number of days between them. But if we press enter right away, we're going to get an error here, which is that it cannot convert the value to a number. So this duration here cannot be converted to a number. Okay, so it's not able to convert the difference between these two dates to a number. So what we need to do is to use another function in order to perform that conversion. So we're going to wrap this argument in the middle here in another function. And it's going to be the number dot from, and we're going to open a bracket here, and we're going to close a bracket here at the end and press enter. And then we get our list of dates all the way until 2014. Okay, so we got our list of dates here, and what we need to do is to convert that to a table. So I'm going to click to table here, and it's asking me here for a delimiter. We don't want any delimiters, and how to handle extra columns shows errors. That's fine, and click OK. And now I have a list with my dates. I'm going to convert this column to a date because this is a date column, and I'm going to name this column date. And I'm going to name my query here, I'm going to name it calendar, because this is going to be my calendar table. And this table, having only one column here, which is the date column, is basically the foundation of my calendar table. And I'm going to be able to create a whole calendar table based on that one column table, or single column table here. Okay, so let's start creating other columns. Okay, so this table here with only one column is going to be the foundation of my whole calendar table, and I'm going to be able to create more columns out of it. So if I select the date column here and I go to add column and I can go to date, I can create some extra columns easily. So I can go to year here and click on year, and this will add a year column here to my calendar table. So as you can see here, I have a year column. I can also go to date again and then go to add column, date, and then out of that date, I want to add another column, which is going to be in the month here. I'm going to add the month. So this is going to give me the month number. Okay, so for January, it's going to give me 1, and so on and so forth. And then I can go again, select the date column here, add column, date, and I can also get the name of the month, right? And the name of the month here is the full name of the month. And this is too long for me, so I can shorten it by selecting the column itself, going to transform, and then going to extract. And I'm going to extract the first 3 characters. So first characters, I'm going to extract the first 3 characters and click OK here. And this is going to shorten the month name. And I can actually create more columns. I can go to add column here. After selecting the date column, I can go to date, and of the day, I can also create the name of the day, a column containing the name of my day, so Sunday, Monday, Tuesday, etc. And I can shorten that column as well by going to Transform tab and then extract, and extract the first 3 characters, just as I've done with the month name. You can also create a column for the week number for that particular day using the date functionality as well. So you can select the date column, go to add column, and then date, and then under week here, you can create the week of the year. However, you will be restricted to how the dates are set up on your computer. So if the starting day of the week is set up as Sunday, then the computer is gonna do it this way. Your starting day of the week is gonna be Sunday, and your week number is going to be created based on that. If your starting day of the week is Monday, then it's going to do it like this. Your week number is going to be based on that, and so on and so forth. However, if you want to customize that and also make sure it works on any computer, so that you would write explicit code that would work on any computer, then it's better to create a custom column. So if you go here under add column, if you go to custom column, and then I want to create a column for week number. So this is the week number for the year. So I'm going to write equals date dot week of year. And then I'm going to open some brackets here and put my date, double click on my date. And then if I put a comma, you can see here, the second argument is the first day of the week. So which day do you want your week to start on? So I will be writing day.Sunday because I want my week to start on a Sunday. If you want yours to start on a Monday or Tuesday or whatever, then just write day.Monday or day.Tuesday. Here, it's actually, there's a spelling mistake, so it needs to be only day.Sunday. And then click OK here. And now we have the week number. So this is the week number of the year. And this should be of a type of a whole number because you could do some arithmetic operations on the week number. So as you can see here, I've created my week number. I can also create a column for the starting date of the week. So I can go to add column, custom column, and this is going to be the week start date. And it's going to be date.start of week. And I'm going to open some brackets here. And I'm going to put my date and then a comma. And then it's asking me for the first day of the week. So I'm going to put day.Sunday. If yours starts on a different date, then you can put day.Monday or Tuesday or so. And I'm going to close my brackets here. And I'm going to click OK. So as you can see here, now it gives me the starting date of the week. And I'm going to make the data type for that a date. And the last column I'm going to create here is the quarter. But I can actually use the date functionality here to add my quarter. So as you can see here, I can go to date and then quarter and then select quarter of year. However, it will just give me the numbers here, 1, 2, 3, 4. But I want it to look like Q1, Q2, Q3. So I'm actually going to remove this step and I'm going to create a custom column here that can make it look like Q1, Q2, Q3, Q4. That would look better for me. So I'm just going to remove this step here and I'm going to go to add column, custom column, and I'm going to make this column named quarter. and then it's going to be date.quarter of year. And here there is a spelling mistake. And then I need to input my date. So this is going to give me the quarter of the year. However, I need to concatenate Q onto that. And I need to convert the date.quarter of year to text. So I need to wrap this inside number.toText function. So I'm going to wrap this inside the number.toText. So what's going to happen here is that the number created by the quarter of year function is going to be converted into a text, and then we can concatenate it onto the Q letter. So it has to be Q1, Q2, Q3, and so on and so forth. So I'm going to click OK here. So as you can see here, it's going to be the quarter here, Q1, Q2, Q3, and so on. And I'm going to convert this to a text. And that's it for now. I can create more columns if I so wish. However, I don't need more than that for now. Okay, so I know that we spent a while here in the Power Query editor, but the thing is, if you're giving an introduction to Power Pivot, you cannot not use Power Query, because Power Query is the tool that most people use in order to load data into Power Pivot. I know that there is another way to load data into Power Pivot without using Power Query, but most people use Power Query for the reasons that I mentioned earlier, which is because it has more data manipulation options and so on. So in order to load the data into our data model, there's a close and load button here, but don't click on the button here at the top. Click on the arrow here, and then don't click on close and load. Click on close and load too with the dots here. That means that there are more steps after it. So if you click on close and load too, what we want to select here, because we want to load our data to the data model, so we want to only create a connection, okay? And this will only create a connection to the data in the memory. And then we're going to tick add this data to the data model. So this will load all the tables that we created. We will load them to the data model. But if you click on table here, then it will load the table to a worksheet here in Excel, which is not what we want. We want to only create a connection and add this data to the data model so as to load all the tables to the data model. So I'm going to click OK here, and this will load all my tables here. It's loading all my tables to the data model. So now it's finished loading here. If we go to data and then manage data model, or if we go to Power Pivot and then manage here, you can see here that now we're starting to see the tables. We're starting to see tables here. So we've got the customers table, we've got the products table, we've got the sales table, we've got the territories table, and we've got the calendar table here. And we can still do more data manipulation to these tables if there's something that is not right with these tables. So I can close my Power Pivot window here. I can go back again to data, get data, and then launch Power Query editor in order to go back to my Power Query editor to fix anything that I don't like, do more data manipulations, and then close and load my data again. Here, there's no close and load to because the data is already loaded into the data model. So it's just close and load, and this will load your changes if you had made changes, but I haven't made any changes, so there's no loading of data here. I'm gonna go back to my data model. So as you can see here, I've got my tables, and now there is another view here that is called the diagram view that is going to show you the tables as a diagram. So as you can see here, you've got your tables here as a diagram, and we're going to get back to this diagram view. But before doing that, I'm just going to close here my Power Pivot window, and I'm going to try to create a pivot table out of my data model. And let's see what happens. So I'm going to insert a pivot table. I'm going to insert it in the existing worksheet. So in this worksheet here, and I'm going to click OK here. And let's start inserting here a field from the products table. So I'm going to insert here the product name on the rows section. And I'm going to go to my sales table. And then I have here an order quantity column here. So I'm going to insert that in the summation of values section. And this should sum the values for my order quantity. And as you can see here, I'm getting the same value for all the products, which doesn't seem right, right? I'm getting the same value, which is 274,914 for all my products here, which this does not seem right, because what you would expect is to slice this data by the product name, right? So as to tell me what's the order quantity for the all-purpose spike stand, and it should be different from the AWC logo cap and so on. It should slice this number. So this number is actually the total order quantity for all the orders on the sales table. So why is this number not being sliced by the product name? Why is it not showing the individual order quantity for each product name, the summation of the order quantity for each product name? And that is because we have not created relationships between our tables. So this is actually part of what makes Power Pivot unique from the normal Excel. You can create relationships, and these relationships are like pipes or wires between your tables that allow you to slice your sales table, or what we call in a data model a fact table. So in a data model, your sales table is going to be called the fact table, and you can slice that by different dimensions. And one of the dimensions here that we've got is the product. So the products table is a dimension table. The customers table is a dimension table as well in a data model. And the calendar table is a dimension table. And the territories table is also a dimension table. So these relationships allow you to slice your fact table by different dimensions to give it context. So I'm going to go back here to Power Pivot, and then I'm going to go to Manage, so as to go to the Power Pivot window, and I'm going to start creating relationships between my tables. So I'm going to go to the diagram view, and as a best practice, and this is by Power Pivot expert Rob Colley, as a best practice, you should put your fact table here at the bottom and put your dimensions table on top of the fact table, because this makes it easy for you to imagine that you have your relationships, because when you create a relationship, the relationship goes from your dimension table to your fact table, and it's going to be a one-to-many relationship, and I'm going to explain to you what that means. But first, let's create the relationships. So I'm going to create a relationship between the calendar table and the sales table, which is through the date column here, the order date and the date column. So I can drag from the date table here on the calendar and drop onto the order date. And Power Pivot is going to detect that this is a one-to-many relationship. As you can see here, the one side of the relationship is the calendar table, and there is a 1 here on it. And then the many side, which there is an asterisk here indicating many on the sales side. And what this means is that the calendar table has the date column having unique values. So the date column on the calendar table contains each date only once. I'm just going to go back here to the calendar table. I'm going to show you that each date is repeated here only once. There's no repetition of the dates on the date column here on the calendar table. Whilst on the sales table, you can see here that the order date can be actually repeated. So if I sort here oldest to newest, you can see here that the order date is repeated here on the order date column. I'm just going to clear the sorting here, but as you can see here, the dates are repeated. So this is why this is a one-to-many relationship. On the one side, the values are unique on the column having the relationship, and on the many side, the values are repeated. And on the territories table, I'm going to link the territory ID with the territory ID here on the sales, and on the products table I'm going to link the product ID with the product ID here on the sales, and it's a one-to-many relationship as well. And as you can see here, the one-to-many relationship as well here, it means that the territories table contains unique territory IDs, right? But the territory IDs on the sales table are repeated. And the same goes for the product ID, and also for the customer ID. I'm just gonna drag and drop here on top of the customer ID on the sales table, and that means that the customers exist only once on the customers table, and they are repeated on the sales table, because a customer can make several transactions, make several sales transactions with us. And the reason for placing the dimensions tables, or the tables on the one side of the relationship on top of the fact tables, Okay, so why are we placing them on top like this is that the filtration through the relationship, it happens from the dimension table to the fact table. So that means that the dimension table will filter the fact table. So our customers table will filter our sales table, our products table will filter our sales table, our territories table will filter our sales table, and our calendar table will filter our sales table. However, the opposite will not happen here. So the sales table will not filter the customers table. The sales table will not filter the products table. The sales table will not filter the territories table, and the sales table will not filter the calendar table. So the filtration happens from the one side to the many side. So this is why we're placing them on top. So as you can imagine that the filtration is flowing just like water in a pipe from the top to the bottom, right? Because water would normally flow from the top to the bottom, unless you have a pump, of course. But imagine that you don't have a pump, then water will flow naturally in the pipe from top to bottom. So this is why we're placing our tables this way, in order to be able to easily visualize the relationships and how the filtration happens and the direction from and to where the filtration happens. So now, after creating our relationships, if we close our Power Pivot window and check our pivot table again, you can see here that now we're starting to get numbers that make sense. Now our order quantity measure that we created here, so what we created here is a measure, but it is an implicit measure, not an explicit one, and I'll explain the difference between an implicit and an explicit measure shortly. So this measure is now being split by the product name because of the relationship that we created between the products table and the sales table. And now the filtration is working, and that is why we're getting numbers now that make sense, which is basically that we're getting the summation of the order quantity for each product here. So for this product, we're getting the summation of order quantity on the order quantity column. We're getting the summation of that column for this particular product here. So now we're starting to get numbers that make sense because we managed to create our relationships. Okay, so let's speak about calculated columns and measures in DAX. So I'm going to go here to my Power Pivot window, and I'm going to go to the sales table. And as you can see here on the sales table, we do have an order quantity column and a unit price column. So I can create a calculated column that multiplies the order quantity by the unit price in order to get the sales amount. So I'm going to create here a calculated column, and I'm going to give it the name of CC. So I'm going to give it a prefix of CC for calculated column, and then I'm going to name it sales amount. So CC sales amount, and I'm going to start typing the formula, which is the order quantity by the unit price. So in order to type the name of a column, it's the best practice that you would have the name of the table first, and then you insert the name of the column between square brackets. So equals the order quantity, but you need to type the name of the table first. This is not mandatory, but it's the best practice in order to distinguish a column from a measure, because when you type the name of a measure, you type it between square brackets. But if you type the name of a column with the name of the table before it, then you know that this is a column, because measures are just typed between square brackets without the name of the table, because measures are not attached to a table. Although when you create a measure, as we will see later, it will prompt you to attach it to a table, but measures can be attached to any table. Attaching them to a specific table is not mandatory. So right now I'm gonna multiply the order quantity by the unit price. So as you can see here, sales order quantity by sales unit price. I'm going to press enter. And as you can see here, the order quantity has been multiplied by the unit price for each row in the table. So this formula has been applied for each row in the table. And the reason it's been applied for each row is because calculated columns have what is called a row context. So that is what a row context does. It iterates and it applies formulas row by row. So this is a calculated column for you, and it is going to be stored in memory of your computer, in the RAM of your computer, and also it's going to occupy space on your hard disk as well. So it will increase the size of your model. So this is why it's a best practice to try and reduce calculated columns as much as possible. So you can still create calculated columns, but create them when you have to create them only. And they are mostly used for slicing tables. So this is what their use is, in order to slice tables. If you need to slice tables by certain categories, then you create calculated columns if you need to. So if you need to aggregate the sales amount, or if you need to get the total sales amount for this whole table, then you can create a measure summing this column here, the sales amount. So you can create a measure that basically sums this column, but you can do something else, which is that you can use the SUMX function instead of the sum function in order to do the iteration and the summation in one step. So this is a calculated column for you. It has a row context and it applies formulas row by row. So this is one of the main differences between a calculated column and a measure. So I'm going to close my Power Pivot window here. Okay, so now we're going to create our first measure here. So I'm going to go to the Power Pivot window, and then I'm going to go to measures and then new measure, and I'm going to create a measure called sales amount wrong, because we're going to do it first of all the wrong way, and I'm going to attach that to the sales table. So you can see here it gives you the option to attach the measure to a certain table. It will work the same regardless of which table you attach it to, but here I'm going to attach it to the sales table because this is calculating the sales amount. So I'm gonna create a measure which is gonna be basically sum the CC sales amount column on the sales table. And this is, again, doing it the wrong way. We should not be doing it this way. And I'm gonna show you the better way of doing it. So this will basically sum the whole column, because the sum function doesn't have a row context, so it doesn't go row by row. It will just sum the whole column. So this is just gonna sum the CC sales amount. Okay, and I'm gonna give it the data type of a currency and with 0 decimal places, and there's a check formula button here to make sure that your formula does not have any errors, and certainly mine does not have any errors. So I'm gonna click OK here, and now I can start adding that measure to my pivot table. So if I click on my pivot table here and then go to my sales table, you can see here the measure exists here, so I can just drag it and drop it here, and as you can see here, now it's calculating the sales amount correctly, but this is not the right way of doing it. So it's not like this amount is wrong. It is right. The calculation itself is right, but the way of calculating it is not the most efficient way of doing it. So this is why I called it sales amount wrong. Okay, so the right way of doing it, or the more efficient way of doing it, is to basically use the SUMX function. So I'm gonna call this just sales amount, and I'm gonna attach it to the sales table as well. So the better way of doing it is to use the SUMX function. Okay, so the SUMX function, it does have a row context. So it can go row by row and apply the expression that I'm going to give it. Okay, so the first argument, or the first input for the SUMX function, is the table that I want to iterate through. Okay, so I want to iterate through the sales table. I want to go row by row on the sales table. And then what's the expression? What's the formula that I want to apply row by row? It's actually the order quantity on the sales table multiplied by the unit price. So this is the formula that I want to apply row by row. So I want to iterate through each row of the sales table, and I want to apply this formula. Please multiply the order quantity by the unit price. And after doing that, row by row, I just want to sum the whole column. So think about it as creating a virtual column here on your table where you've multiplied the order quantity by the unit price. So you're going row by row, multiplying order quantity by unit price, and then you're just gonna sum the whole virtual column that you created. Okay, think about it like that. So this is what this measure is gonna give us, and it's gonna give us the exact same results as sales amount wrong measure here. So this is gonna be a data type of a currency, 0 decimal places, check my formula, no errors, click OK, and as you can see here, the measure has been applied, and it's giving us the exact same results here as the sales amount wrong measure. However, this is more efficient because we did not have to create a calculated column in order for that sales amount measure to work. So I'm just gonna delete the sales amount wrong measure here. I'm just gonna delete it, and I'm gonna also delete the CC sales amount calculated column because we don't need it anymore in our case. And I'm gonna close, and as you can see here, this measure is not dependent upon the sales amount calculated column that we created. So this is a better way of doing it. And the reason that this is a better way is that this consumes less memory on your computer, and it doesn't consume disk space as well, because measures, they calculate on the fly. So they only calculate whenever you use them. And that is unlike calculated columns, because calculated columns get calculated each time your data is refreshed, and also the results of the columns are stored in memory. Okay, so if you've got a column that is 1,000,000 rows, then the results of the 1,000,000 rows are stored in memory, and this consumes memory. While in case of measures here, they only get calculated on the fly, and they use CPU power. They don't use the memory of your computer. They just get calculated by the CPU of your computer, by the processor. Okay, so they don't use any memory on your computer, and they don't use hard disk space. So this is why making your calculations in measures whenever possible is a good way of ensuring that your model has the smallest size possible. And you will find yourself, when you're using Power Pivot and DAX, that you're creating more measures, certainly more measures than calculated columns. So from my own experience, for example, I create maybe 8-9 measures for every one calculated column that I create. That's my own personal experience. So actually between 70 and 80% of your calculations are going to be done in measures as opposed to calculated columns. And another characteristic of measures is that they get calculated according to the filter context applied. So this is what the term filter context is, which is basically the combination of filters available in each cell here in the pivot table. So the filters that are available at this moment, for example, is basically the product name. This is the only filter that is available right now on this pivot table. So it's calculating the sales amount for each product name. So this is the sales amount for each product name on the sales table, the total of the sales amount for each product name on the sales table. Okay, so measures, they have a filter context, and they can also use functions, of course, that can iterate row by row, like the SUMX function that we've seen that do have a row context as well. Okay, so we've seen the optimal way of using a measure when we created the sales amount measure, but the way we used a calculated column when we created the CC sales amount calculated column was not the optimal way of using a calculated column, and it's not the actual way that a calculated column should be used. So we're gonna see an example of how we can utilize calculated columns in a better way. So I'm gonna open here the Power Pivot window again, and I'm gonna create a calculated column. And this calculated column, as you can see here, we've got a unit price discount column. And this calculated column will calculate the discount percentage, and it will categorize that percentage into low or medium or high or no discount categories. So as you can see here, this is a unit price discount. This is in terms of a currency, so you can think about that as $0.3, for example, and this unit price is $4.99. So we're going to imagine here that if the discount is greater than 0 and less than 5%, then this is a low discount. And if it is between 5 and less than 10%, so greater than or equal to 5 and less than 10%, this is a medium discount. And if it is greater than or equal to 10%, then this is a high discount. And if it's 0, then it's a no discount. And we're going to create a calculated column to slice our data this way, and we're going to be able to use that calculated column in a slicer, for example, to slice our data. So I'm going to create a calculated column here called discount category, for example, or discount type, discount category. So this discount category will yield low, medium, or high, or no discount. So I'm just going to use an if function here, and it is the same as the if function that you'd use in normal Excel. So the logical test here would be that I'm going to divide the unit price discount by the unit price, and I'm actually going to use a function called the divide function, and the divide function will just divide the first input by the second input. So it's going to divide the numerator, and the numerator here is going to be the unit price discount. So I'm just going to give it the unit price discount here. I'm going to divide that by the unit price. So this is going to be the divide function. It will just divide the first argument by the second argument. So if this is greater than 0, so if this amount is greater than 0, and here in Power Pivot, if we need to write an AND condition, we can just write 2 ampersands, or we can write the AND function and put everything inside the brackets of the AND function, but this is just easier to just write 2 ampersands. So if it is greater than 0, and also here the divide, so I'm just going to copy the divide function here. If it is less than 0.05, which is 5% here, so if it's greater than 0 and less than 0.05, then it is low. And otherwise, if the discount is greater than or equal to 0.05 and the discount as well is less than 0.1, which is 10%, then give me a medium. And if the discount here is greater than or equal to 0.1, then give me high. Otherwise, give me no discount. And then I'm just going to close my brackets here. Okay, and I've closed all my brackets. So as you can see here, this is just an if function, just like the if function that you write in normal Excel. I'm going to press enter here, and this will classify my discount as low, medium, and high, and no discount. So now we're able to slice and dice our data using that calculated column that we created. So I can go here to sales, and then this is a discount category. I can right click, and then I can add that as a slicer, and now we can slice and dice our products by high, low, medium, or no discount, as you can see here. So as you can see here, this is the better use of calculated columns. This is how calculated columns should be used. They should be used to slice and dice your data, to create categories to slice and dice your data. Okay, so on this pivot table, we have two different measures. We have this sum of order quantity measure, which we created by dragging and dropping the order quantity column onto the values section of the pivot table. And we have this sales amount measure, which we created by going to the Power Pivot tab on the ribbon, and then going to measures, and then going to new measure, and we created the sales amount measure this way. So as you can see here, we followed different steps to create the two measures, and they are actually different because the sum of order quantity measure is called an implicit measure, while the sales amount measure is called an explicit measure. So they are two different types of measures. Well, they are both measures and they yield results. However, there are differences between them, and certainly explicit measures, like the sales amount measure that we created here, is the preferred way of creating measures. So first of all, let's speak about implicit measures. So implicit measures, they are created by just dragging and dropping a column here onto the summation of values section, just like you do in classic pivot tables. However, they do have drawbacks. First of all, you're limited to just certain calculations, the calculations that a pivot table can do. So when you go to the value field settings, this is all classic pivot tables, so you're limited to these calculations only, or show values as these calculations. So you're limited to certain calculations. You can't do any type of customized calculations outside these calculations that are standard on a pivot table. So that's one thing. The second thing is that when you create these measures, and this will certainly appear here on the grand total section, they are not formatted automatically. So when you create them, you have to reformat them every time. So for example, this number 274,914, it would be better if this number would always be inserted and formatted as having a comma here to separate the thousands, and removing the decimal places too, so that we'd be able to read the number easier. It's easier to read the number this way if we have a comma, right? 274,914. So implicit measures, they are only limited to the calculations of the standard pivot tables, and they do not have a number formatting by default, and you have to format them every time you insert them. Okay, so if we remove this sum of order quantity, implicit measure, and we drag it and drop it again, you can see here that the formatting that we had done before has vanished, it's disappeared, and now we have to format it again. So that's one difference. But for the sales amount measure, which is an explicit measure, and this is one of the reasons explicit measures are better, whenever you remove it and you put it back, sales amount, it will always have the same formatting because we have set up its formatting here on the measures. When we created a measure here, right, we set up the formatting to be a currency. It will always be inserted as a currency. It will always have that formatting. No matter how many times you remove it and re-add it, it will always have this formatting. Plus, of course, when you create the explicit measures, you have the freedom to write whatever formula you'd like to write here. So you can do customized calculations on explicit measures. So this is why explicit measures are the better way of writing measures, definitely, or of creating measures. And it's a good practice for DAX developers. And you will see that the better DAX developers, they always create explicit measures and they don't create implicit measures. So that's the difference between implicit and explicit measures. Okay, so let's demonstrate the power of Power Pivot and DAX by creating even more measures. So I'm going to go here to a new sheet and I'm going to insert a new pivot table here. So I'm going to insert a pivot table and we're actually going to do some calculations for the year. So I'm going to drag the year column from the calendar table. And what we need to calculate, the first calculation we need to do is how many days we sold on, or how many days we did sales on. So if we go here to our sales table, if we need to calculate how many days we did sales on, so we need to calculate the unique number of dates here on the order date column, right? So what we're going to do is that we're going to create a measure to calculate that. So I'm going to go to measures, new measure, and this measure is going to be attached to the sales table. Of course, it will work regardless of where you attach it. And we're going to create a measure how many days we sold on. So for this measure, we're going to calculate the unique number of dates on the date column of the sales table. So we're actually going to count the rows. We're going to do a count rows, and we're going to use the values function here with the date column of the sales table. So the values function, it actually returns the unique values of the order date. It would return the unique values of the column, of whatever column you put inside it, but it will return them as a table. So this is why we're going to use the count rows function. So the output of the values function is that it outputs a table. Even though you gave it a column, it will output whatever the result is, it will output it as a table. So this is why we need a function to count the rows of a table. So we're going to use the count rows function. Okay. So this is going to be a number. It's going to be a whole number, of course, because it's the number of days, and we're going to click OK here. So this will give us the number of days that we did sales on. So you can see here that we didn't sell on the whole of 2011 because we started in 2011, and we didn't sell on the whole of 2014 as well because our business ended in 2014, in the mid of 2014. So we didn't do sales in the whole of 2014 as well. And we're also going to put here our sales amount measure as well. So this is our sales amount measure. So this will show us how much sales we did on each year. And now the next measure we're going to create is the average sales per day. So the average sales per day is simply going to divide the sales amount by the number of days we sold on to get the average sales per day. So I'm going to go to measures, new measure, and this is going to be the average sales per day. And this for this measure, we're just going to divide here the sales amount by how many days we sold on. And this is going to be a decimal number. We're not going to use any decimal places, and we're going to use a 1,000 separator, and we're going to press OK here. So this is the average sales per day here for each year. And this is useful to know which year was our best year because, for example, the year 2014 was a better year than 2012. right? Even though the total amount of sales in 2012 is greater than 2014, but compared to the number of days we did sales on, the average sales per day in 2014 was better than 2012. So at a first glance, it could be deceiving, and you could think because the sales amount, hey, the sales amount of 2012 is greater than 2014, so 2012 was a better year. No, 2014 was a better year because we achieved 20 million of sales in half of the year, as opposed to 33 million of sales in the whole of the year 2012. So this is a good measure about which year was a better year for us. Okay, now we're going to calculate the number of orders that were made. So I'm going to go here to my Power Pivot window, and on the sales table here, you can see here that the order ID here is actually repeating here on my table. So if I actually sort that smallest to largest, you can see here that the order ID does repeat. So each order actually includes several items, several products with different product IDs. So we need to compute the unique number of orders. So we need to remove the repeated values here from the number of orders. So we're going to do the same thing that we've done here on the order date. So I'm going to go back here and I'm going to create a new measure, and then it's going to be the number of orders. And this is going to be the count rows of the values of the order ID column here, the sales order ID. And we're going to close our brackets, and this is going to be a whole number. So we're going to use 1,000 separator as well, and we're going to click OK. So as you can see here, this gives us the number of orders that we had. Now we can also get the average number of orders per day if we divide the number of orders by how many days was sold on. So we can do that definitely. Average number of orders per day. So this is going to be the division of the number of orders by number of days, how many days we sold on. And I'm going to close the brackets here. So this is going to be a decimal number, but we don't want to show the decimal places. And we can use 1,000 separator, and then we're gonna click OK here. So as you can see here, this will show us the average number of orders per day. So as you can see here, for example, 2014 had the highest average number of orders per day. Now the last measure we're gonna create here, and this will show us the power of the filter function in DAX. We're gonna calculate the sales amount for orders having items with a discount between 5% and 10%. So let me go to the Power Pivot window here real quick to explain to you. So we're going to calculate the unit price discount percentage. We're going to calculate the discount percentage, which is by dividing the unit price discount by the unit price. And then we're going to filter this table here, and we're going to do that all in the measure, all using the formula. We're going to filter the table for items having discounts between 5 and 10%, and then we're going to calculate the sales amount for those items. And we're going to do all that in the measure. We're not going to create a calculated column to do that and then divide our table. We're going to do that all within the measure, and this is to illustrate the power of DAX and the filter function. So I'm going to close that, and we're going to go to measures, new measure. So this is going to be sales for orders having discount of 5% to 10%. So this is actually sales for orders having items with discount 5% to 10%. So the first thing to do is we're going to actually create a variable here, and this variable will contain the table that we need to filter our sales table with. So this is going to be our filter table, and this is going to be TBL discounted orders. I'm just going to name it the TBL discounted orders. So this variable is actually going to contain a table, and we're going to build this table using the filter function. So we're going to filter the sales table for orders having we're going to divide the unit price discount by the unit price, right? And we're going to test if this is greater than or equal to 0.05. And we're going to test as well. Let me just increase the size of the window here, and we're going to copy that expression. We're going to test as well if this expression is less than or equal to 0.1. So the discount is between 5% and 10%, and that's including the 5% and the 10%. Okay, and this is going to be our filter table here, and the result. So we're going to create another variable here called result. So this is going to be calculate. We're going to use the calculate function to calculate the sales amount only for that particular table. I'm going to insert that particular table as a filter. So the filter of a calculate function is actually a table, and we're not going to go in depth about the calculate function or the filter function at the moment. We're going to leave that in the course, but I'm just trying to show you here and demonstrate the power of DAX. So I'm going to insert as the filter, I'm going to insert the TBL discounted orders here, and then we're going to return the result. And this is going to be a currency here, and it's going to be with 0 decimal places, and we're going to click OK. So as you can see here, we managed to do the calculation for the sales for orders having items with 5% to 10% discount. And by the way, here for the average sales per day measure, we actually missed making the unit for that one a currency. So we should make it a currency, and that's been done. Now we can actually check our calculation if we build a calculated column. So calculated columns, another use for them is that they're great for checking your calculations. So let's actually do that. So I'm going to go here to the Power Pivot window here, and let's create a column here for a discount 5 to 10%, 5% to 10%. This is going to be our column here. And this column will do a check if the discount is between 5 and 10%. So we're actually going to do divide the division of the unit price discount by the unit price. We're going to check that this is greater than or equal to 5%. And we're going to check as well if it is less than or equal to 10%. I'm going to press enter here. And as you can see here, it gives us a series of true and false values here. So first of all, if we select only the true, which is the one matching our criteria, you'll see here the total sales amount is 37,135,095, which matches our total here. Okay, so this gives us an indication that our calculation is correct. And we can also do some more checks by, for example, bringing over the year column from the calendar table. So this is going to be another calculated column here. I'm going to name it CC year. And then I can go to the calendar table and bring over the year column from there, related calendar year, and press enter. And as you can see here, now we have the year. And if we filter for the years as well, we can get the sales for the individual years for that particular condition here, for discount between 5 and 10%. So for 2011, for example, 4,249,101. So as you can see here, it matches the number here. And so this shows us that our measure is calculating the correct amount. So I know that this has been a long video, a long tutorial, but I think it was a good demonstration and a good introduction to the power of Power Pivot and DAX, and I think it should give you motivation to learn Power Pivot and DAX. So thank you so much, guys, for watching this video.
If you like the video, press the like button and share it with your friends. Subscribe to the channel and hit the bell icon so that you'll be notified with all the new videos. And please make sure to follow me on social media and subscribe to the newsletter so that you can get all the new updates and videos. You will find the links below in the description. If you have any comments, suggestions, or feedback, please leave them below in the comments section. Thank you so much for watching this video, and I'll see you on the next one.